Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 1382. It's a balance binary search tree. Okay, so the problem what we have given is we have given a binary search tree, right? BST we can say that, and the tree is not balanced here. Okay, that means some branches are too deeper. As you can see, it start from root node 1, 2, 3, 4 like this. So some, not some only, but maybe there is more branches on a given subtree. It will come down. There is some more cases also there like this. So we can say that some branches are too deeper and the height difference between the left and subtree is large, right? Because you will take this absolute value, obviously it become more than 1, right? That is not the case for the balance that we have seen in the last video, right? If you have gone through my last video, you will understand what is a balanced tree and how we'll check it is balanced or not balanced, right? If it is not balanced, means only because if the difference left height and the right height difference is called the absolute difference, if it is less than equal to 1, right, it should not exceed 1, then only it become the balance binary tree. We can say that balanced tree. But here some branches are very deep, right? Too deep, or right, and height difference between the left and the right subtree is larger, right? So the operation degrades to O of 1 instead of O log n, correct? Because this is binary search tree, right? BST. So what is our task is we have to rearrange the node without changing the value so that the BST becomes height balanced, right? So you are not inserting a new node here and you are not deleting nodes, right? Just restructure. You have to restructure to make it the height balance of a BST. Let's understand the give me 1 second. Yes, so what height balance is here, right? If you remember, if you've gone through my previous video, you have seen that we have taken the height of, let's call the left subtree, and height of the right subtree, right? So we have taken the absolute value like this, right? We can say, and it should be less than equal to 1. If it is less than equal to, it means this is called a height, HEIT, height balanced. Okay guys, this is called height balance. Don't think what is height balance. Height balance is left, this is left subtree and this is right subtree. Okay, or for every node, let's call, if this is a node, let's call the root node. So we know that there will be some value will be there, right? And for the root node, there will be some another node will be there. Let's call its left, and for this you call this as a right, right? So there will be some value, and maybe further there will be some value, right? Like this. So we have to find the height of this one and the height of this one, left and right, and you will do, there will be some value will be there. We know that there will be some height will be there, and if you're taking the minus, right, means the difference, it should not exceed 1. It should be always less than equal to 1, then only it become the height balance. I hope this part is understandable for you. Okay, now it's very understandable to understand this. This is called, I guess, a skewed BST, right? A skewed means it's a chain like this as a tree. It's called skewed BST. So this is basically a linked list that is called, right? Skew means a linked list, if you remember, linked list. Okay, so this is basically a linked list, guys. So in the very simple step, what you need to do is we can say that step 1 is to in order, right? If you'll do the in order traversal, I'm talking about the traversal, guys, right? Very first you do the in-order traversal. Remember in-order? So in-order traversal of BST gives sorted order, right? Why? Because the in-order traversal let me write in-order traversal gives of BST, you write the BST gives what? Sorted order. Always remember this point, guys. If you will not remember these things, so you cannot implement it. So in-order traversal gives what? Sorted order, right? Let's suppose if 1 2 3 4 we have, you just try, you will do the sorted 1 2 3 4 like this. This is called sorted, right? So you do the in-order traversal. In the next step, what you need to do is called, let's call a step 2. Okay, in step 2 you have to build balanced BST from sorted order. Sorted order, or that we have created a sorted array, we can also say, right? Sorted array. And this is I'm talking about. Okay, the very first step is to do in-order traversal, and you will find the sorted order array, and you will build the balanced BST from the sorted array, right? So you have to pick the element as a root, right? Pick middle element. So the middle element is either this or this. You know that things, right? So you have to pick middle element as a root. Okay, think always. So if, let's suppose, if you want to, there is two chances, right? Either you will take 2. So if you will take 2, give me 1 second. If you will take 2 as a middle, you will build this tree, right? If you will take 3 as a root node, you will build this one, right? So I'm just saying that, right? If you take 3 4, right, it can, there will be one possibility is that we'll take 3 here, then 4 will come here, then 2 will be here, right? And after this true, there will be 1, right? If we will take this part, right, it is now the height difference is minimum here, and it is a balanced one. Okay, so try to pick the middle elements and try to build the BST, right? Balanced BST, and you will find that you have balanced a tree, and the height difference is minimal here, right? And so we will find the tree's balance, because we need less than equal to 1 height difference only, right? And that will work for us. Let's suppose you saying that how we'll find this balanced thing. Give me 1 second. You will say how will we build this thing. So very first, try to understand through the stack, right? If you're doing the in-order traversal, guys, right, it means you have to do the call stack movement. Very first, for this root node, right, what is the left, right? So go to the left, and the left you will find that this is nothing but null, right? If this is null, it means you have to visit now is 1, because in the in order we go for the left, a root, and then a right, like this we will visit, right? Not in the post order. Post order, how we are going? Left, right, and then root, right? But in this case we have to go to the left, root, and right. This is in order. So if we'll go very first is as a left, right, we will visit, and that is null, means we have to visit 1 now. So very first we will visit 1, you will get 1. Okay, then we will come to the right, and right we will see that this is 2, so visit 2, you will get the 2 here, right? Then again same thing you will do, you have to visit 3, visit 4, like this, because this part they have is null, right? And so you have to visit left, root, right for each cases. So this is also a tree, right? When you come here this time, right, you will find this is null, means you will visit this one. Now you will go to the right side, you will find that this is also null. So you will read this one, you will check now this one. Like this you will keep going, you will find 1 2 3 4 like this, right? So array becomes 1 2 3 4, which is very cheaper. Let's think about the building the tree, right? We will use, let's suppose, a 2 pointer, left and right pointer, and we'll build, let's suppose, 0 3 first, the middle is 1 and value is 2, like that we will take. Then we'll tree will say is directly is 2, let's suppose, right? Then we'll go the left side, we'll build again, and we'll say okay, middle is 0, we'll find the value is 1. Like that you have to keep checking the value right side, and you'll keep building the array tree. I will explain the code later. Let's very first try to understand the intuition, guys, right? So the intuition is here, intuition is that it's not a BST here, right? It's not a BST. It is a thing that we have to convert the BST to convert into BST, right? Very first convert into the sorted array. Once you find the sorted array, you need to build balance BST. That is the problem, guys, correct? What you need to do, it is not a BST, so you have to convert the BST into the sorted array, and from the sorted array you have to build the balance BST. This is what we have. Means if you talk about the code idea, very first you do Inorder traversal and find the sorted array. After the sorted array, you have to build the balance BST like a binary search construction, and this will guarantee you the minimal height, perfect structure, almost as a complete tree, right? And overall these things will take O of n as a time complexity. Okay, yeah, we are also storing the array, so we'll take space complexity as O of n. So this problem is becoming easy to implement. Come back to the code. So how we are going to solve this? So let me do this one. Okay, very first we need a list where we will keep adding what you call the list of all the element, right? In the array we can say that where we'll do the sorting everything, right? So let's create a list first, and we will take all the nodes here, so called integer, and this is not the list of node, new array list. Okay, then we'll do the Inorder. We'll create Inorder letter. So let's suppose we'll pass the node, this is our root node, will go, and we'll pass our list here. So we'll prepare the list array also, right? Return a build function, means we want to build a BST, and we'll pass our list of node, start from 0 and go to the list dot size, right? -1, we can go 0 to -1, we know that in the array. Next is to develop Inorder. We'll say okay, private void, it will not return anything, and we'll say Inorder, and we will pass here very first is tree node, and this tree node is nothing but the root node, we can say for now, and this is list of integer we are passing, and that is nothing but the list, our list. Okay, check first if the root is equal to null. If root is null, we will return here, otherwise we'll check in order again, and we'll say okay, left, what is the root? Left, we'll traverse the root left first. In the Inorder we will go for the left node first, then we will also pass the list here, then then we have to visit the root itself, and this is called root dot, this is called visit, right? Then we, after once the left is completed, root is completed, we have to, in order, we have to traverse to the root dot right, and similarly we'll pass the list. So like this, you have to go first the left part, then the root part, and then the right part, right? Like this we will go, and the in order is done, and all the node will be get added onto the list as we have done here, right? Understand? The very first is left, then root, and then right. Like this we have to traverse, and we will add all the values, all the nodes on the all the visited nodes on the list, as we are doing here. We are adding, that is called visit. Now once these are done, we have to come to this point, right? So this part is done. Okay, means all the node is added, visited on the list. Now we'll build this one. So how we are going to build? Let's think. So think that we have a private method, and this will do tree node, it will return, because the return type is node for the balance BST method. Sorry. Then we'll create a build method. We know that very first we need is list node. What if we have list node? We'll pass this list node itself. Then the int left and int right, 2 pointers we needed, correct? To build the 2 pointed, very first we'll check if left is greater than the right, it means we will return null. Okay, in otherwise we'll find mid first, we'll say left plus right minus left. So internally, to find the mid value, we have to use this one, left minus right minus left by 2, and we'll get the mid. Now very first we have to build a node. Tree node is called node. How will build? You will need to call the constructor tree node, and to get the list element we'll say get, and we'll pass the mid. What is the element we have at the mid? So that we will find. Then we will say node dot left. Similarly you will do the build, and you will pass the list and left and the mid -1, and similarly we'll do for the node dot right is to build the value from, this time it will the mid +1, right? Half this one and half this one, because this is sorted one, right? So we have to use half in the left side, half will go into the right side. Like this we have to do. Okay, and then you will return this root node that you have created. Node. Let me try to submit. Okay, so this is your left list, left right. Why it is not taking, guys? List left right, yeah. Tree node build. What is the mistake? L for list, L for list. Okay, it means there will be also issue. I have copied this one. Yes, the code is working fine. Let me submit. Yes, code is also working fine. Okay, so this is what we have to do, guys, right? And let me zoom out a little bit. Yes, so what we have done, we have created a list here, and when we visit the in order, right, we have to add all those nodes on this list as a sorted array, right? And we are not doing any sorting here, but we have to visit, right, and we have to get this, right? So we are building here the value, we are adding the value here, right? And to build the array, we know that we have to find the mid, and from the mid we will take the node here as a root node, and you will create the left and right like this. So for creating the left, we will start from the left to the mid -1, and for the right, mid +1 to the right, and that is what we have to do. Okay, so if other than this, if you want to do, right, that you have to reinsert the node into the new AVL tree, and idea is to, you have to traverse the old tree and you have to insert new node one by one into a self balanced tree. So the pros will be that conceptually it will be clean, but when you are going for the inserting, it will take the cost of O of n, right? And that is the cons you will find there, and that will give you the total time complexity is O of O log n, which is very complex code, right? So you can try that approach also. And there is a DSW algorithm, right? You can also apply, where there is an advanced method will be there, where you will convert the tree into a vine and you'll compress to the balanced tree. And I will try to develop this code into the premium courses, so you can get in touch by me if you want, right? So this is the thing that we will discuss in the upcoming videos. Basically, what interviewer is testing, they want to see if you are recognize BST sorted array pattern, and if you see that, the problem is easy. If you don't, you will overthink that. Okay, so that's all I have in this video, guys. If you are stuck with anything, please let me know in the comment section. And for any learning either Java DSA, you can join in our online classes. You can come for the React also and Angular, so you can join my online classes. So you can ping me in the WhatsApp. I can help you further to enroll in our online classes. So that's all I have in this video, guys, and please keep watching, keep learning, and keep subscribing ExpertFunda and supporting it. Thank you for watching this video. I'll see you in the next one. Thank you.